Okay, hi everyone, student. Today I will start the tutorial. There's a 4.3. I hope you understand the lesson for 4.3. So now I want to discuss this topic. Okay, first one, let's see the tutorial. There's a paper one. They just got 13 of the question. Okay, I will show you all the answer here, 1 until 13. Okay, so you can check your answer. So from here, I want to discuss one of the question. There's a calculation. There's a question 13. Okay, let's see the question 13. Okay, this one is a question 13. We see what they want. Okay, first one, they say they're using the transistor circuit. They got two resistors. There's a P and also there's a S. So from here, the resistor P has a resistance 10 kilo ohm. So that means actually the P is a LDR. Okay, so LDR, that means the resistance that will changes during the day and also the night. Okay, in order the light, you want to light up the bulb. So potential difference across the resistor P at least is 2 volt. So you want to light up this whole circuit, the bulb you want to light up. So at least you need to let the resistor base voltage become 2 volt. So that means they can light up the bulb. So from here, the question they want to ask a maximum value for the resistor S when the bulb to light up. So that means you want to light up the bulb. So at least P, I know there's a 2 volt. Then S should be how many volt? The S must be minus. So the S becomes 10 volt. But now the question never ask about the potential difference. They want to ask about the resistor. So we need to using the voltage divider to do the calculation. Okay, now the question they want to find is R1. So we just apply the equation. Okay, example, we're using the equation V2. Okay, V2 is more easier to find it. Okay, let I show how to do this question. Okay, now we can see V2. So I write the equation. V2 equal R2, R1 plus R2, then multiply with the total volt. Okay, so from here we go and check the total volt is a 12. So 2 volt you want to light up, V2 you want to light up at least is a 2 volt. Okay, R2 is a P is a 10K. So we just write R1 we do know, R1 is a resistor S. Okay, plus 10K. Then you need to multiply, total is a 12 volt. Okay, so from this one equation, you do the calculation. So I just bring the bottom go up. So 2 R1 plus 10K. Then this part is a 120K. 120 kilo ohm. Okay, we just write the K first. Okay, so from here, the 2 I can cut it. So this one become R1 plus 10 kilo. So this one divided by 2 becomes 60K. Okay, finally, I just want to find R1. So I just write R1 equal, okay, 60 minus 10K. So finally, you just left is a 50 kilo ohm. Okay, so this one is the answer. So the answer here is C. So we're just using the voltage divider to solve the problem. Okay, let me go to the next one. Okay, I change first. Okay, let's see the next one. Okay, now the following is the question 14. Question 14 also one of the calculation. Let's see the question what they want. Okay, the diagram they show about transistor circuit in order to trigger the alarm. Okay, they want to trigger the alarm X. The potential difference across the NO must at least 1 volt. So we label first. Okay, for the you want to trigger the alarm, at least here is 1 volt. NO is it? So this one's 1. So there's a 1 volt. So we just label 1 volt. Okay, now you're going to see the next one. The question. First one, they say what is the potential difference across the MO. MO means overall. So overall, we just copy the answer here. Overall is a 6 volt. Okay, then we go to the B. When the resistance of the resistor P and also the Q are 500. If both also 500, so we label. Here 500, this one also 500. Okay, what is the potential difference across the MN? Okay, MN means the first one. Okay, they ask you what is the potential difference across the MN. Okay, so from here, okay, we just divide, is it? Because 6 volt is from M to O. Okay, now your both resistance is the same. If both resistance is the same, so I just divide by 2. So I just take the 6 volt divide by 2. Both same resistance, so must take the same voltage. So from here, your answer is a 300. Sorry, it's a 3. Okay, erase first. Okay, so from here should be 3 volt. Okay, every resistance is the same. So that means that we get the same potential difference. So from here, there's a 3 volt. Okay, for the every resistance. Okay, now we go to the next one. Okay, so from here, the question 2, they ask about what happened to the alarm X. Okay, what happened to the alarm X? So from here, we follow the just now question. Just now question, they say 3 volt, is it? 3 volt, they say what happened for the alarm. 3 volt, is it can trigger the alarm or not? Actually can. We can trigger the alarm, okay, by 1 volt already. So that means just now it's a 3 volt. So that means we can trigger the alarm. We just answer number 2. Okay, they ask you what happened to the alarm X. So we just answer the alarm will be triggered because they said at least it's 1 volt, because just now we get already every resistance you get 3 volt. So that means they can trigger. So we just answer the alarm X is triggered. Okay, then we go to C. When the resistance of resistor Q is 500. Okay, so from here they say Q is a 500. And the resistance of the resistor P is a 4000. Okay, now the situation changes. You need to determine the potential difference across the resistor Q to show the alarm X is not triggered. Okay, so that means you need to show the answer for the Q must less than 1 volt. Okay, if less than 1 volt, that means they cannot trigger. So we need to prove lah V2 is how many. So we do the calculation. Okay, so from here, we show the calculation how to find out the V2. So you want to find out the V2, so we're using the formula V2. Okay, so V2, the formula should be R2, R1 plus R2, multiply the V. So this one's the formula. So the V2, we know the V2 is how many? The V2 we don't know, is it? You want to prove, is it? So from here, not trigger the alarm. So from here, we just write the V2, we don't know. So R2 is 500. Okay, R1 is 4000 plus 500. Okay, after that we multiply with the total. Total is a 6. So we find what's the answer for V2. So V2 will multiply 4500. So this one will become 500 multiplied to the 6. This one is 3000. Okay, so from here need to find the answer for V2. 3000 over the 4500. So I get the answer here. Okay, let's check the calculator first. Okay, 0.67 volt. 0.67 volt means less than 1. So less than 1 means I can prove 0.67 volt less than 1 volt. So finally I can say cannot trigger. Okay, so this one is a final answer. We prove already the 0.67 volt. That's a less than 1. So that means we can say they cannot trigger the alarm. Okay, let's see the next question. Okay, now the question is give you the table. The table they show the variation of the resistance of the thermostat. Okay, with the temperature they provided. Okay, now the temperature and also the resistance, there's a fix. Okay, different temperature, they can produce a different resistance. So now they say when the resistor P, okay, now the P, they want to replace with the thermostat. So what is the resistance of the resistor Q? They want to find the Q resistance is how many? So we just drop down first. They want to find Q is how many? Okay, if the alarm X is triggered at 200 degrees Celsius, means the alarm X you want to trigger at 200 degrees Celsius, mean this part. Okay, 200 degrees Celsius, mean the thermostat, here become thermostat, so I draw again, this one become thermostat, so thermostat like this. So this one is at least is 1750. Okay, 1750 means they can trigger the alarm. Now they want to find what is the resistance here. So our formula we need to find is RQ. Okay, so from here we using the formula, you want to find the RQ. Okay, let's see here. At least you want to trigger the alarm, you need 1 volt. So resistance for the thermostat at least is 1750. So we still know this one is 1 volt, this one is 5 volt. If I using 1 volt, I also can do the calculation. I using 5 volt also can. So let's see if I using 5 volt. 5 volt, that means V1. V1 is R1. R1 plus R2 multiply with total. So V1 we 5 volt. So R1 we know already 1750. This one is 1750. They plus about the R2. Okay, after that they multiply with the total, there's a 6. So we do the calculation here. So this one 5, we move another side. 1750 plus R2. Okay, this one is multiplied, become the 6 calculation. So I do calculation first. Okay, so you give me the 17 times, this one is 0, so 5, 3, 3, so 42, 45. For 500, okay, 10,500. So now finally I want to find R2. So that means you do your calculation there. So finally I get the answer R2 actually is RQ. So it's 350 ohm. So this one is the answer for the RQ. Resistance Q, there's a 350 ohm. So if you want to trigger the alarm lah. Okay, then we go to the next question. Okay, now the question, they're still using the table. Okay, there's a temperature, also the resistance for the thermostat. Okay, P also replaced, become thermostat. So we still drawing, there's a thermostat. Okay, this one still thermostat. Okay, now the temperature is required to trigger the alarm X when the resistance of the resistor is 1000. Okay, so here become 1000 already. Okay, is it? Okay, the temperature trigger X when the resistance of the resistor is 1000 ohm. Sorry, it's 1000 ohm is a Q. Okay, we check back. Okay, now the question is, okay, bottom. Okay, they say they want to trigger the alarm X when the resistance of the resistor. Okay, resistance of the resistor means the bottom one. Bottom is a resistor, up become thermostat. So you want to trigger alarm, at least this one must be 1000 ohm lah. Okay, this 1000 ohm is a 1 volt. Is it? You want to trigger the alarm, follow the question 14. Okay, now the question they want to find is what's the temperature of the alarm? This one, the thermostat. What's the temperature? So you need to find the temperature here, must know resistance. So we need to find is a P. RP is how many? So we do the calculation again. V2 equal R2, R1 plus R2 multiply with the total V. Okay, now we know the R2 at least is 1 volt. You want to trigger alarm, at least is 1 volt. Okay, so R2 is 1000. Okay, R1 we don't know. Then this one is 1000. Okay, then you multiply with the 6. Okay, so from here we get the answer. It's straightforward. Do the calculation. You can get the answer. R1 is a 5000 ohm. Okay, but the question they don't want ohm. They just want the temperature. So you refer the table. So I get it. 5000 ohm actually is a 55 degrees Celsius. So this one is the answer what they want. Okay, 55 degrees Celsius for the thermostat. That means they can trigger the alarm X. Okay, we go to the next one. Okay, the next one is another question. That's question 8. Show about the transistor circuit. Okay, we're using is the LDR. This one symbol is for LDR. Okay, the circuit they use automatically switch. You want to switch on the bulb. Okay, they got add one more. There's a relay switch. So understood what's the function for relay switch? Relay switch just want to increase the output voltage. Maybe they're not enough. So you want to using the second switch to make the output voltage bigger. Okay, now we're going to see the first question. They ask you what's the name of the component Q. Okay, what's a component Q? Okay, component Q is a transistor. So we give the perfect name, full name. Can you see the arrow point outside? So this one is a NPN transistor. Okay, we put full name, NPN transistor. State the two function of the component Q. So they ask about transistor is what's the function. Okay, so from here we can mention the function. So from here they become the automatic switch. Okay, there's an automatic switch. They also can become the amplifier. Okay, so this is a function for the transistor. So what is the function of the resistor R? Okay, first one, resistor R. What's the function? So the function they want to limit. Okay, they want to limit the base current. Okay, do not let too much current go through the transistor. Okay, what happened to the potential difference Vp at the night? Okay, remember when the LDR you put at the bottom, the situation is night that will on. Okay, if you put at the top means the situation is chacat one. Chacat one means what? At the day they on the light. So now when they put at the bottom means they can on the night. The light can be on during the night means the potential difference is large. That's why base current can trigger the transistor. So that means now the question they say at the night what happened for potential difference? Your answer should be bigger, or you say increases. Okay, because of increases, so they produce a bigger base current. Okay, so this one is no calculation, just ask about the question. Okay, we go to the next one. Okay, now they say explain why the bulb is light up at the night. So we're using the concept lah. Okay, during the night, you must say the resistance of the thermostat. This or not thermostat, this is LDR. During the night, LDR resistance is high. Okay, when it become high, then what happen? The potential difference automatically become increases. Then they got base current pass through the transistor. Then the transistor just on, they can switch on the collector current. Then the collector current can be switched up the bulb. Okay, let's see the answer. Okay, as the resistance of LDR increases, so the potential difference across the base current will trigger transistor. So from here, the collector current flow through the transistor and switch on the bulb. So you must mention about resistance first. Number 2, potential difference increase, then base current. Then after that, you must say collector current flow, then the bulb light up. Okay, so this one is a LDR function during the night. Okay, we go to D. Okay, D is a calculation. Bulb M is label. Okay, bulb M means the last one. 240 volt, 60 watts. Start to light up when the Vp is 2 volt. So Vp means the V2. V2 is 2 volt. So we just write. Okay, if you want to light up, V2 at least is a 2 volt. V2, you want to light up, at least there's a 2 volt. And the resistance of the resistor P. Okay, resistor P means the bottom, the LDR. Okay, the LDR must be 10 kilo ohm. Okay, determine the maximum resistance of the resistor S means the R1. Okay, now the question they want to find R1. Okay, so we're just using the formula for V2 lah. V2 equal R2, R1 plus R2, then multiply the V. V. Okay, now we're going to do the calculation. Okay, V2 is a 2 volt. At least you want to light up lah. R2 we know already. R2 is a 10 kilo. So we just write there's a 10 kilo. 10K. Okay, R1 we do know. So R1, then 1 plus 10K. Then multiply the volt. We see the total volt is how many? Total volt is a 6. Okay, then you do the calculation. So finally, I get the answer. This one 2, I move here. 1 plus 10K. Okay, this one is a 60K. Okay, divided by 2. So R1 plus 10 equal 120. Okay, so the K you want to put it, just put 10 kilo. Okay, finally R1 is how many? So we just do the calculation. Now R1 is 120. I divide, sorry. This one not multiply. This one is divide. So after divide, they become 30. So we just write here, there's a 30. So 30 minus 10. So your left is a 20 kilo ohm. Okay, so from here, there's a 20 kilo ohm for the resistor S. Okay, we go to see the next one. Okay, what happened to the bulb when it is connected directly to the transistor circuit without using relay switch? That means we're never using any relay switch. Okay, we straightforward connected the bulb with the transistor. Okay, connected the bulb with the transistor without using a relay switch. Then should be what happened. So you see the answer here. Okay, the bulb actually does not light up. Okay, why? Because flow of the low voltage. Because your collector current just now, the total base circuit just 6 volt. So the bulb you want to light up at least is 240 volt. So that means there's not enough to trigger the output voltage. So they must using the relay switch. Okay. So our lesson just until here only. So hopefully you understand about the tutorial 4.3. If any question you don't understand, that means you can PM me, ask about the calculation. So from here, just thank you for your watching. The next one should be lesson 4.4. Thank you.